go for it.
All right.
Sips coffee.
Okay. I believe we are live.
Woo!
So let us get started. All right. So welcome everyone to the first Very Good Ventures live stream. Hopefully there will be more of these in the future. Today we are going to take a look at Mason, which is an open source library made in Dart that helps developers create and consume templates called bricks. It's what powers Very Good CLI, right? And it's what you can use to make templates, whether that's like a Flutter app, a widget, as Felix will demonstrate shortly. It's a pretty powerful tool, similar to some other tools out there, right? Like Cookie Cutter, I think is the
in
other
the Python
one.
community. Yep.
Yep. So there are a bunch of other tools that are similar to this, but this one's kind of interesting because it's made with Dart, so you can kind of do some interesting, fun things with that. So before I hand it over to Felix, I do want to say that we are open for questions. So if anyone does have any questions, feel free to add them to the live stream chat on YouTube. I will read them aloud because I did not connect our live stream correctly.
Technical difficulties. Go easy
So
on
I
us.
will, go easy on us. It's our first live stream. But if you do have questions, I will read them aloud to Felix. So hopefully we can answer them. I see some people in the chat. Hello, Rodrigo, Boris, Sergio, and Marcos, and anyone else who's watching. I will hand it over to Felix now.
Awesome. So as Scarlett mentioned, we're going to be talking about Mason, and thanks to everyone for joining and tuning into our very first live stream. So I'll start by just sharing, if you want to present my screen, I'll just start by going through the repo on GitHub, since as Scarlett mentioned, it's just an open source project that you can check out on GitHub. So let me know, are we good, Scarlett? Because I can't see anything.
Yeah,
I'll assume yes. Okay,
we're
cool. So, and feel free in the comments to let us know if like things are too small and you can't read them. I'll try to make the font size bigger. But yeah, as Scarlett mentioned, basically Mason is just a Dart tool that allows you to create and consume templates that we call bricks. And as she mentioned, Very Good CLI uses Mason internally. And for those of you who don't know, Very Good CLI is just an open source tool that we use at Very Good Ventures to help create new Flutter projects, plugins, packages, etc. So if you want to like kind of put your own spin on like what a package looks like, or your company has like a set of standards, or maybe like you've evolved your approach over time and you found that something works well for you, and you want to kind of like create your own starter that's like a little more sophisticated than maybe Flutter Create, Mason is a really good tool to help you do that. And we'll see in a bit how. But I highly encourage, if you haven't already, to just read through the docs. Hopefully it gives you all the information that you need to get started. I'll do a live demo in a second of like, assuming you don't have Mason installed, what do you do and how do you create your first, generate your first piece of code. But yeah, the README is full of a bunch of different kind of applications and like technicalities of how to use Mason. And it is a command line tool at the end of the day. So you can just always do like Mason -- help or -h at any time in your command line and see the list of commands. One thing before we just jump right in that I want to mention is, as of now, Mason does use the mustache templating language internally. So all of your templates that or bricks, I'll start calling them from now on, that you define in Mason will be written in Mustache. And so if you haven't checked out Mustache, it's a really simple, small spec for how you can have templates that's pretty old and mature. It's been around for a long time. It's really like simple and bare bones, but it supports basic things like injecting different variables into your templates, looping through arrays of values, having conditionals, like maybe if this value is true, show X or render X, otherwise render Y, those types of things. So definitely, if you haven't checked out Mustache before, you might want to read the Mustache manual. It's really short and it just has like a couple of different examples because Mason doesn't have any like proprietary templating language or anything like that. It's just leveraging the existing Mustache language thanks to a port from the Dart community. So there's a package called mustache_template that Mason uses internally. And so, yeah, without further ado, I guess let's just jump right in. I'll try to go through like a quick start. How do you just get up and running with Mason? How do you generate code with Mason? How do you define your own custom templates with Mason? And we'll see what we can do in like the next 35 minutes-ish, and then I'll try to leave time, as Scarlett mentioned, at the end for questions. So let me flip over to VS Code. So in VS Code, hopefully everyone can see this. Let me know if it's too small, but basically I just have an empty directory here. There are no files. It's just a workspace called Mason Playground. And if you haven't installed Mason before, I'll assume that everyone has Dart installed. If not, I definitely recommend installing Dart before doing any of this. But assuming you have Dart installed, you can do a Dart pub global activate Mason. And that will install Mason from pub.dev, which is the Dart package registry. You can also use Homebrew if you're a Mac user, but I think universally the Dart pub global activate is my recommendation for most people. And once you have Mason installed, you'll know you have it installed because you can just type Mason in your command line, and you should see something like this, where you get like some basic usage. You can also check what version of Mason you have just by running Mason -- version. And so at this point, you have Mason installed. Congrats, that's step one out of the way. And the next thing that you probably want to do is just set up your environment so that you can quickly just play with Mason, generate an example piece of code from a brick. And the easiest way to do that is to run the Mason init command. And so you can see a lot of things just happened when I ran Mason init. So I got this output that said, we generated 3 files. We generated a mason.yaml file. We generated a folder called bricks. And then we generated a folder called .mason. So .mason, ignore. It's a file that basically helps Mason figure out where all of your templates are locally. And it's something that I would git ignore, for example, if you're committing this to a repo in GitHub, for example. So .mason, just ignore for now. This is only just like for Mason to figure out where things are, and it should only live on your machine. You don't need to share that file with anyone else. The important ones are this mason.yaml and bricks.yaml. So I'll try to go through them slowly, and if anyone has questions, just drop them in the chat, and then Scarlett will read them to me, and we'll try to answer them in real time. So you can see the mason.yaml that gets generated has some comments that it comes with. So basically, think of the mason.yaml as like your pubspec.yaml if you're familiar with Dart or Flutter. Basically, it's like a pubspec.yaml, only rather than defining your dependencies and your dev dependencies, it specifies or defines your bricks that you want to be able to use. And you can have different mason.yaml files in different directories on your computer or in different workspaces to define the different types of templates that you want to be able to use. And anytime you use the Mason command line, it will look for the nearest mason.yaml configuration that you have, like the nearest parent mason.yaml configuration you have, and then it will read from that and give you access to those bricks that you have defined. And so how do you define a brick? The simplest way is to just specify the name of the brick and then where it's located using path. And this path would be a local path. So in this case, we have a brick named hello, and it lives in my local directory under bricks/hello. So that's all you really need to do. You can also import bricks from a Git URL. So I can, for example, uncomment this guy over here. And we have a brick called widget for all the Flutter developers out there. And that brick lives in this Git URL under this path. You can also specify a ref, for example, like if there's a specific tag on that Git repo that you want to use or a specific commit hash. So a lot of things are, there are a lot of similarities with how pub.dev resolves packages and how Mason resolves bricks. And so basically, now that you have your mason.yaml and you've defined however many bricks you want, you can run a command called mason get. And mason get will install the bricks that you have defined in your mason.yaml. And then you should be able to do a mason list to see, okay, what bricks do I have available at this point? You can also do mason ls for shorthand, same exact thing. And so you can see, like, we have a hello brick, we have a widget brick specified in our mason.yaml. One thing to note is, let's say I switch directories out of that Mason playground folder, and then I run mason ls. I don't have any bricks anymore, right? Because there's no mason.yaml defining the bricks that are available. So for now, we'll get into global bricks in a second, but for now, everything that we've done is scoped to the workspace that you're in. So let's go back into Mason Playground, and we have our bricks. So now, as you can probably see in the comments, the way that you would use these bricks is using the Mason make command. So Mason make, and then the name of the brick. So let's start with the hello example. So if I run Mason make hello, Mason's going to check, okay, what does this template actually need in terms of variables? And then it's going to prompt me for any variables that aren't specified. So in the case of this hello brick, there's one variable that that template needs, and it's a name. And so I can specify, okay, my name is Felix. And, oh, Felix. And then if I hit enter, you'll see that Mason generated one file. It is called hello.md, this markdown file, in my current directory. And if I open that file up, I see hello Felix. And by default, Mason make will generate the brick output in your current directory, but you can also customize that. So for example, if I want to do Mason make hello, and I want the output to live under docs, for example, I can do Mason make hello -o for output directory. And then let's say let's do dash this time. Let's say dash. So Mason will now generate the output in the target destination, which is this docs folder. So now I have hello dash under docs. So that's important to note, that you can control where Mason puts the generated files using -o. And now let's say I'm happy with the Mason generated code in the docs folder. Let me delete the main one. So now we just have hello under docs. And let's say I want to run it again. But instead of having Mason prompt me, let's provide the input via command line. So I can directly via command line specify all the values that I want Mason to use in the template. So if Mason has everything it needs via the command line arguments, it won't prompt for anything. And so in this case, you see Mason didn't prompt me, but it did say, hey, there's a conflict, meaning like, hey, Felix, you told me you want to generate this file under docs that's going to be called hello.md, but there's already a file in docs that's called hello.md. So what do you want me to do in this case? And you have a couple options here. So the capital Y means like, yes, always, basically. So if there are multiple conflicts, since you can have multiple files as part of a brick, if you do a capital Y, it will basically overwrite every single change. Lowercase y is a little nicer. It's like, okay, this one I want you to overwrite, but still prompt me if there are other conflicts in the future. N is for no, so skip it, leave the current file the way it is. And then A is for append. So leave the file the way it is, but append the newly generated output to the end of the existing file. So let's just go with yes to overwrite in this case. And so you can see immediately the file was overwritten. I have hello Felix now instead of hello dash. And if I want to also specify this via command line, let's say you're running this in like a CI environment or something like that, where you don't want to be answering Mason's questions dynamically like that, and you want everything to be provided via command line args, you can specify on conflict and specify the conflict resolution. So in this case, we can say overwrite. And let's change the name again back to dash so that we can actually see a change. And now you'll notice like, okay, Mason didn't prompt me for anything. I gave it all the variables that it needed via command line. I gave it the conflict resolution strategy that it should use if there is a conflict, and I gave it the output directory. And so Mason's like, okay, cool, I have all the info I need. I'm going to just generate the file without asking you for anything. And so that's kind of a little bit about how you can use Mason to generate files. One last thing, actually, let's say like you have a brick that has multiple variables. I'll go into like what a brick looks like in a second, but let's say for now, this hello brick has like a couple of different variables. Like let's say there's a name, there's a, I don't know, a favorite food, favorite color, etc., that the brick needs. And so by default, it'll prompt you for multiple things every single time. And it might not also be convenient to pass those via command line arguments just because it's a lot of typing. You can also create a configuration file. So let's just say hello.json, and then specify all my variables in a JSON format. So let's go back to Felix. And what we can do this time is we can do Mason make hello. Let's still keep -o docs. Now, let's say I want you to use this configuration file called hello JSON, and then let's do on conflict overwrite again. So we have hello dash, and it will get overwritten with Felix. But this time it's reading from this configuration file, which is really handy for, like, for example, if you're using Mason to generate a whole Flutter project and you want to ask the user, like, what flavors do you want? What bundle ID do you want to use? What's your project name? What's your project description? It can get pretty long and tedious to manually provide all that via command line arguments. And so the configuration file approach works really well for those use cases. So that's a little bit about, we've seen how to generate bricks. Actually, before we move on, we all have this widget brick here that we installed. So we can also just Mason make widget. And it's going to ask me for the name of my widget. I don't know, let's call it like cool container. And we can see Mason can generate Dart code as well. And this is, it's going to complain just because I don't have Dart, or I don't have a pubspec.yaml, and I don't have Flutter or anything defined in this workspace. But you can see that Mason is kind of language agnostic. You can generate Markdown files, you can generate Dart code, you can generate JavaScript, TypeScript, whatever you want to use. Mason doesn't really care. It's just a general purpose tool to help you create reusable templates. And so while I'm at it, let me quickly create an analysis options and exclude bricks so that the analyzer doesn't yell at me later. And let's delete the Dart file that got generated. And let's just jump into now taking a look at what does a brick actually look like. So we have one brick that was generated for us when we ran Mason and init. It's this hello. And every brick basically just needs two things. It needs a brick.yaml and it needs this underscore brick underscore folder. So starting with the Mason or the brick.yaml, this is basically just like your pubspec.yaml, but for your brick. It defines like what's the brick's name, what is the brick supposed to do as like a short little description, and then any variables. Optionally, it doesn't need variables, but if your template is dynamic and requires input, then any variables that the template relies on, you would specify as vars. And then everything that's in this underscore brick underscore folder, think of this folder as like this magical folder that whatever's inside of it is what's going to get generated when you run Mason make. So in this case, it's just one file called hello.md. But in practice, it could be multiple files. It could be folders with files inside of them, with more folders inside of them, with more files inside of them. You get the idea. Like it could be really a sophisticated directory structure with like a full-fledged project inside. And it doesn't matter what it is, whatever is in there, when you run Mason make, it will generate that code. It will interpret all those templates, and then it will render them using the correct variables that are provided. So in this case, we just have one file, hello.md, right? We've already seen this. And when we generate it, we see hello.md with Felix. We can modify the file name to also reference the variable as well. So let's say I want to change my brick to hello underscore the name of the user. And let's say I want to run, let's just do the configuration again. Actually, let's do command line again. We'll do dash. So I have Felix and I'll rerun that. So now, instead of just generating a hello.md, it generated a hello underscore dash with hello dash. And now I can run it again. And let's do Felix. Oh, I spelled Felix wrong, but it works. It generates another one. And you can see that basically you're not limited to just the contents of the file. The actual path of the file name, you can use, you can reference variables and use the mustache spec more or less within the file names themselves. And so let's check out a couple of like interesting things that you can do with Mason and mustache. So I'm going to delete these guys, and you'll notice that, for example, here I specified the name. Let me type Felix correctly. I specified the name Felix, and it just generates the file exactly the way I typed it. So like, let's say I always wanted it to be uppercase just because I wanted to match the hello. How would I do that? In Mason, there's this concept called built-in lambdas. And lambdas are a thing that are part of the mustache spec. So you can check out the mustache spec for more info. But basically, they're things that allow you to modify your variables before you render them. And so Mason comes with a bunch of pre-built ones. And so, for example, there's an uppercase lambda. And so every time you use a Lambda, you basically specify the name of the Lambda, and you have this opening tag with a hashtag symbol and then the closing. And so in this case, it's going to print out hello, and then in all caps, the name that we entered. So if I save this and rerun, we'll see Felix's all caps. And we can also apply that to the file name itself. So we can do the same thing, uppercase. Let me make this a little bigger so you can see it. So we have the opening tag, and then we have the closing tag, right? So it's going to be hello underscore uppercase name dot markdown. I rerun it, and now we'll see it's ignoring because it's not case sensitive on my file system, but let's rerun it. There you go. You see that now you can apply those changes to the file path as well. So that's kind of handy for things like I want to use snake case for Dart file names, or I want to use Pascal case for class names, things like that. And that's kind of actually how that widget template works. When I run Mason make widget and I pass a name, this name, it's going to get converted to snake case for the file name and Pascal case for the class name automatically. So let's say I specify like a very cool widget, right? This isn't a legal name for a Dart file, and it's not a legal name for a Dart class, but it will automatically convert that to snake case to make it conform to the style that you should be naming your files in Dart. And then the class name will be also modified to basically adhere to Dart's naming conventions and to be a valid class name, etc. So Lambdas are your friend when it comes to formatting user input in various ways, depending on the type of template that you're generating. So that's kind of a bit about Lambdas and an example of how to use them. I guess the next thing that we should look at is let's create our own brick. So I'm going to delete, actually, I'm going to remove this template. So going back, you remember if we do a Mason ls, it will tell us the names of the templates that we have available. So you can do Mason remove and then the template name from the command line, and it will remove the template. In this case, it'll remove the template locally. The brick is still there, but if you look at the mason.yaml file, you'll notice the brick is gone. We just have the widget brick. And you can also remove the widget brick. So now we have no bricks. And similarly, you can use Mason add. And let's say I want to add, let's do it from scratch. I want to add a brick from source path, and the path is bricks hello. It will add that brick.
Question.
Yep.
Alejandro wants to know if you can create your own custom lambdas.
Not through Mason yet, but that's a good idea. That's something that I've thought about in the past, and it's just a matter of how we want to define that API. But yeah, if that's something that you're interested in and you think would be super useful to you and you have an idea of what that could look like, definitely open an issue, because that's something that would be a super cool addition. Right now, I can show you quickly on the repo. If you scroll down to template, we have a table here with the built-in Lambdas. So you can see all the ones that Mason provides out of the box. But yeah, I guess at a minimum, if there's one that you think would be really useful that's not in here, it's really easy to add them in Mason. But if you want to be able to define your own outside of Mason, definitely open an issue with a proposal for how you think that should look. And then we can discuss how to implement it and add it to an upcoming version. That's a great question. Any other questions while we're paused, or is that the first one?
There was one that you answered already.
Okay.
About overwriting arguments, but
yeah.
you already covered that. So
yeah, that's a common
keep
thing.
Your questions coming in the chat if you have them.
Yeah, definitely interrupt me if I should stop and talk more about something. So picking up where we left off, I was just going over how you can add and remove bricks from the command line via Mason add and Mason remove. So I've added the hello template back in, so we have it if I run a Mason ls. But I can also add templates from Git And like, let's say I want to add a template that lives in GitHub and in the Mason repo that's under, let's just do widget for consistency again. You can just Mason add like normal, so you don't have to manually be modifying this mason.yaml file. You can just use the command line to add and remove bricks as you like. And before we jump into making our own brick, one last thing I want to touch on that's super useful is like, I kind of mentioned originally that all of this that we've done so far is scoped to this workspace, which is great. Like if you're on a team and maybe you have like a bunch of custom bricks that you use on a specific project, and maybe those bricks only apply to that team and that project, and you want to keep them as part of the repo, like you can define bricks locally and you can have your mason.yaml file, or you can even have the bricks referenced via Git URL on some other repo. But if you recall, if I leave this this directory, this Mason playground, and I do a Mason ls, I no longer have access to those bricks. So everything is relative to the workspace. And so you might be wondering like, okay, what if I have a brick? Like, what if this widget brick is something that I want to use anywhere, regardless of where I am on my machine in my file system? Let's say it's something that's useful no matter what project you're on. How would I actually take advantage of that? And the way that you would do that is you can Mason add and then add it the way that you normally would. So source git yada yada yada. The only difference is you specify -g for global, or you can type out --global. They're both the same. And when you do that, it'll tell Mason to install this brick as a global brick. So if I do a Mason ls here, nothing will really change. It's still the same as before. It looks like we have access to both. But now if I leave this this directory and I check out what bricks I have available, I also have this widget brick that I installed globally. And just like with remove and removing things locally, you can Mason remove -g widget to uninstall the global widget. So now we're back to, we have an empty directory, and then I can re-add it again if I want to. So yeah, the command line for Mason is your kind of like best friend when it comes to adding and removing bricks, whether they're global or local. It's up to you, and whether they live on your current like local file system or whether they're on Git, it's also up to you. It's kind of, it just depends on the type of template and how you want it to be used. But you do have that option. So now I can, for example, run Mason make widget --name cats, I don't know, and it'll generate a file called cats in the current directory, which is one level up. And you can see like we're no longer inside of the Mason underscore playground. So let me remove cats since we don't need it and come back into Mason playground. And yeah, let's take a look at how to make a new brick basically. Like let's say you're like, okay, this is all cool, Felix. I kind of get how Mason works. Now I want to kind of use it to make my own templates. What does that process actually look like? So the first thing to do is, again, just use the CLI and do Mason new and specify the name of the brick. And since I assume most people here have a background in like Flutter and Dart, I will use just like a Dart package as an example. So let's say like you're a developer who you kind of like made a couple of packages in the past, and like you always start off with Flutter create or like some other basic like scaffold for a package. And let's say like over the years, you've like picked up a few things that you really like to do every single time, and you manually do those, or you like copy and paste from a previous project, and you're finally like, okay, let me make this into a template so that every time I create a new package, I start off with my like best practices and my style and everything out of the box. How would I do that? So you can just do Mason new and then the name of your template. So let's call it like cool package. And then you can also specify a description. And let's say like a cool Dart.
We have another question.
Package. Yes.
So Marcus wants to know, where do the global templates live on your system?
Yes, that's a great question. So it depends on if you're on Windows, Mac OS, Linux, but you can check out the Mason source code if you want to have a really specific idea of where it is on your local file system. But for example, on Mac OS, they live in your home directory .mason cache. And you can see the directory structure is similar to your pub cache. So there's the git installed, the global installed, and then like let's say if I go into the git installed You can see I have a couple of different ones here. This is just, it's not going to look like this for you. This is just because I develop on Mason locally, and so I have different copies of Mason installed. But this .mason cache folder is where your dependencies will live. And actually, since I have a global one now, yeah, the global, you can take a look, it has basically like a top level mason.yaml, which specifies all of the bricks that you want to be able to use from anywhere. So if you ever delete this .mason cache folder, you'll have to basically run mason get again or mason add -g again. Everything that Mason uses that's cached on your machine lives in that folder. So that's a really good question for if you're like wondering, does Mason kind of like build up a ton of like stuff in my computer and use up a lot of space over time? Not really. All these templates should generally be like really, really small, and the footprint should be pretty small. But if at any point you're like, oh, I'm sick of Mason, I want to delete everything off my machine that has to do with Mason, you can just delete the whole .mason cache folder, or if you just run mason remove, it will delete everything, especially if you remove globally, it will remove the relevant files from the Mason cache for you. So great
All
question.
right. So follow-up questions. Two of them are kind of, I think, getting at the same thing. So one, does a collection of bricks exist, e.g. for Flutter, or is there a way to publish and see bricks from the community? So like a
Not,
central
yeah,
repository.
not yet, but that's kind of like one of like our hopes/dreams for the future, that there will be a central place where you can publish bricks and version them just like you do packages on pub.dev. So stay tuned for that. If you're interested in helping work on that, definitely reach out and let us know. Or if you think that would be super useful for your team or your company, let us know. Because obviously the more interest there is from the community and the more momentum we can get behind it, the easier it'll be to justify working on it. But at the moment, there is nothing really. The closest thing to that would be if you create like a public GitHub repo where you just host a bunch of brick templates, and then people can just point to the bricks via Git URL, and you can specify, like I mentioned earlier, a ref. Let's say like you have a tag like v1.0. Then this is the closest thing to like a central brick registry that we have as of today. But I think that's something that I've always had in the back of my head that would be like amazing to have. And would make this a lot more complete and a lot easier to kind of contribute and consume community created templates. So yeah, hopefully that'll be something that comes up in the future that we work on. So
Okay,
yeah, good question.
one more question for now before we let you get back to it. So how do you update bricks which have been installed with Git URL?
Yeah, so if you want to update a brick via Git URL, you could just run a mason get again. So like let's say I'm always pointing to the main branch on Mason, and I'm always downloading this bricks widget. This is kind of like the really loose way to point to this brick. Like for example, if I push to the main branch and I update this bricks widget, the next time I run mason get, it will check, is there any update? If so, it'll install the update. Otherwise, it'll just keep the local version. But it also is smart enough to know, like if you don't have a network connection, it'll just use whatever you have cached. So it's not going to ruin your installation locally if you're offline or you have a spotty internet connection. But if you do have a good connection, it will always check to see, are there updates to the brick? And then it'll try to install those updates before moving forward. So mason get is pretty much like what you just run if you want to make sure that things are always up to date. And like I mentioned, this .mason folder, it basically is kind of like your it's kind of like the .packages folder in Dart or in Flutter, where it will kind of keep track of what are the bricks that you have, where are they on the local file system. It will hash them so that it knows like when were they last modified, etc. So the metadata for what's installed lives here. And whenever you run a mason get, if there's something new, it'll update locally, and then if needed, it'll adjust the references in your bricks.json in the .mason folder. But again, like you don't really have to worry about this as a developer. You never really have to modify this file or this folder. Like I mentioned, you probably actually want to just git ignore it and like forget that it even exists. But yeah, long story short, mason get, and you'll get any updates if your reference in your mason.yaml is broad enough to encompass those updates. Like obviously, if I had a ref here that was v1.0 and I made updates on main, but they weren't tagged with v1.0, and I run mason get again, then I won't get those updates. So just like how pub works and when you use git references for pub packages. Cool. Okay, so those are all really good questions. I forgot where I even was. Let's see. What was I doing? We talked about globals. We talked about, we are creating our own brick. So like I was mentioning, we have the Mason new command where I can specify the name of my brick. So let's call it cool package, and then description, a very cool Dart package. And if I run this command, it will generate that brick for me locally. So now, in addition to the hello brick, we have a cool package brick, and it'll also automatically, I think, yeah, it will automatically add it to the mason.yaml. So as soon as you run Mason new and create a new brick, you should be able to see that newly created brick when you run a Mason ls or a Mason list. And by default, it'll just create like a simple example, just like the hello one, more or less. It'll have your package or your brick name and your brick description. But in terms of the content, it's pretty bare bones. So at this point, it's up to you as a developer to customize this. So like, let's start off. Let's say that we're creating a package, right? The first thing every package needs is a pubspec.yaml, right? And our pubspec.yaml has a name. So let's make this a bit more specific. And rather than just name, let's make our variable package name. And then now here we can do package name. And then in our description, let's create a package description variable. Let's add that variable to our brick.yaml. So now we have two variables. And then let's say this is just going to be a pure Dart package. So let's say it's going to require greater than 2.12.0, less than 3.0. So we have null safety. And let's say we also want to have some tests. So let's add package test. I think 19 is the newest version. So we have a pubspec.yaml, right? Now we can immediately test that this works if we go back to our terminal. And let me delete everything that's irrelevant here. So here we go. I'm also going to even just delete the hello brick because we don't care about that one. And we can remove everything from our Mason YAML and run a Mason get again just to clean everything up. And so now if I run a Mason ls, we just have, we have our global widget. Let me remove that as well so that it's not in our way. So now we just have our one cool package. And we can test what we just created by, one thing I actually forgot is we want everything to be inside of a folder, right? We don't want our files to just get created in the void, like wherever you are. We want them to all be inside of a folder called package name. So now our folder structure looks like, here, let me just print this out. Bricks, and then you can see we have cool package. Inside of cool package, we have our brick folder. And then inside of that brick folder, which is everything that gets rendered when you run a Mason make, we have a folder that's going to be called package name, whatever the package name is, and then a pubspec.yaml, right? So now if I run a Mason make cool package, it will prompt me for my package name. So I don't know, let's call it like cool cats. And then the description, I don't know, some description. So now it generated, because by default it's in the current directory, it generated a folder in our current directory called cool cats. And then all these files got generated automatically by the Dart extension on VS Code. But really the only thing that Mason generated, as you can see here, is this one file, pubspec.yaml, that has our package name and some description. And it has the environment and dev dependencies on the test package. So we know everything is working. So now we can start building things out, right? Like every package has a lib folder and a source folder inside of that. And like maybe in our lib folder, we have, again, package name .dart, and maybe we have our library, right? And then we want to export whatever's in source. This is all up to you to define as someone who's managing this or maintaining this template. And let's say in source, we have, again, package name .dart, and we have class. Now here, we probably want to use Pascal case package name, since this is a class name. And we should also go back and do snake case for all the other ones. But for the sake of the demo, we have a class package name that's in Pascal case. Let's also create a constructor for that class. Let's make it a const constructor. And then let's give it a single method called, I don't know, greet that prints hello world, right? And let's also create a test folder at the top level. And then let's create a file called package name test.dart. And then here every test has a main, right? And we have a group, I don't know, package name tests, and yada, 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 right? You'd have some tests here to do, right, tests. You can go crazy with this and have like pre-made tests for your package, depending on how crazy you get with the implementation of the actual package itself. But let's just leave this for now as this basic package. And so if I rerun this again, let me actually delete coolcats and let's rerun this again, but let's specify the output directory to be inside of a packages folder. And then let's specify the, let's do the prompting. So we'll do coolcats again, and then some description. So now you can see it created under packages coolcats. Coolcats has a valid pubspec.yaml. It has a test folder with coolcat tests. It has a class called coolcats, which defines a method called greet, and it exports all that. So now you can add coolcats as a dependency in some other project and then create an instance of it and call greet. We should have probably said the same meow if we were being funny, but yeah, you get the idea. So we just basically created a simple template for a Dart package. If you maybe throw like your favorite lint rules in here, cough, cough, very good analysis, or any other package, or any other linting package in here out of the box, you can have that pre-configured anytime you create a new Dart package. You can also obviously add a README, which I highly recommend when you're creating new packages, and make your README as crazy or minimal as you'd like. Basically, like this is yours to personalize. And then you can throw this up on GitHub or keep it locally, whatever works for you, and then reuse that template over and over and over again. And I know we're almost out of time, but the very last thing I wanted to show is Mason is not just a command line utility. As we kind of mentioned really early on, it's also a Dart package that you can pull in as a dependency. And so you could, for example, use a command called bundle to basically generate a bundle out of an existing brick. And a bundle is pretty much just one file that is kind of like a minified, like compressed version of all of the information that Mason needs in order to generate code from that brick. So we can do Mason bundle, and let's bundle our cool package. And let's say that it's going to be a Dart bundle. -T is for the type of bundle. Since we're going to be using it in Dart, the type is Dart in this case. And then let's say our output directory is going to be, let's actually output it in packages coolcats lib source. This is going to be kind of interesting, but you'll see where I'm going with this. So basically, Mason generated this bundle. You can see this bundle is valid Dart code, except for it depends on Mason. So if we were to add a dependency on Mason here, 001 dev.55, and save that up, this should all compile. So now we have a bundle. And in Dart code, now you can actually, let's create another method called generate. Let's make it async. And we can create a generator using Mason generator dot from bundle. And we can pass our bundle, so our cool package bundle that we generated using Mason. So I know this is getting kind of hard to follow, but we created a brick. We used that brick to generate a package using Mason. And then inside of the output that we just generated, we're adding code to use that same bundle and generate something new. You probably would never want to do this. It's probably not actually useful, but it's kind of interesting. And I wanted to demo how you can use the bundle and actually programmatically generate code from a bundle. So you can get a generator, and then with the Mason generator, you can call the generate API, and it takes a target. So let's say I want to be in the current directory. And then let's just use the default logger that comes with Mason. And let's await this. Normally you'd have some like try catch logic and actually like error handling and things like that. But for the sake of the example, let's just keep it simple. So 3 lines of code. We create a Mason generator from a bundle. We call generate on that generator. We tell it where to generate the code. And then if everything is successful, we print success. So now we can create an example folder within our coolcats package with the main.dart to test this out. So we can say final coolcats equals coolcats. And then we can call coolcats.generate. And one thing I forgot is since our coolcats template requires input variables, we define variables in our template. Remember, we have a package name and a package description. We need to also specify those here. So package name, let's specify that via a required name. And then maybe we can have an optional description. For now, I'll leave the description out. You can fill that in. That'll be like a homework assignment for people if they're interested. And then we can just default it in here. So a default description. And now in our example, we can say our name is, I don't know, let's call it like cooler cats. And let's just output done. And so now if everything worked well, we have this main.dart file in the example directory, not Mason, dart example main. So I'm going to run this. It's going to use our generated class and call generate on it, which uses Mason's API to programmatically generate from a bundle. And so I'm going to just run that directly in coolcats. This is probably a bad idea. But you see, we generated another package inside of coolcats called cooler cats. And it has cooler cats, a default description, cooler cats, etc. So we went full circle, basically. We by hand made a brick for Mason, used that brick to create a package, and then within that package, we used Mason's API to programmatically create a new package. So it's packageception, basically, and Masonception. And I think with that, I'll stop there since we're almost out of time and want to make sure if anyone has any other questions, we can answer them.
I guess you really like cats.
Yeah.
We do have one question. Mauro wants to know, could this be used as an alternative to code generation in Flutter/Dart?
Yeah, definitely. I think it just depends on your use case. The thing that code generation has that Mason doesn't is the ability to like introspect your code. So like with code generation, you typically will annotate classes, think like JSON serializable, and then the code generator will look at those classes that are annotated, inspect them, and then generate code based on those annotations. That's currently not something that you can do with Mason, but Mason is really good for cases where, let's say, for example, I always generate my data class the exact same way. It always has a copy with, it always has a from JSON and a to JSON. You can create a brick for that, and then you could just do Mason make data class and give it the name and give it where you want that data class to live, and then you're done. And the nice thing about that is it scales really well because it doesn't matter how big or small your project is. It will always take the same amount of time to generate the code, whereas Build Runner, as you probably know, like over time, it does get a bit slower as you have more and more files that it has to analyze. And especially if you have dependencies between classes that get code generated in Dart, it tends to slow things down quite a bit. So I think it all depends on your use case, but there are definitely cases where you can use Mason as like a drop-in for some things that you might normally use code generation for, but not everything. I think code generation in Dart still has use cases that make sense to use the native tooling. Also, not to mention that it's built into Dart. So you don't like, especially with the static metaprogramming proposals and things coming up in the future, it's probably going to be a lot more convenient to use code generation in Dart than it currently is, and you hopefully won't have to run like that build runner build command manually and things like that. But yeah, if there are cases where things are self-contained and you don't rely on inspecting existing code to figure out what to generate, then Mason is a great tool for that, because then you're not really limited by the size of the project, and it will take milliseconds, as you saw, every single time, regardless of how big the project is. And just to give you a sense, like Very Good CLI generates a fully fledged Flutter federated plugin that has like iOS, Android, Mac OS, Linux, all the different like base implementations that you would want if you're creating a cross-platform plugin, and it does all that in like a second or less than a second. So really, it's pretty fast, regardless of how many files you're generating, which is nice.
All right, I have a question.
Go for
Can
it.
you tell us a little bit about how Mason came to be? Like, why did you even start working on this tool?
Yeah, that's a good question. So basically, it all started when we were trying to kind of optimize our workflows as developers at VGV, and like we found ourselves doing like pretty similar things over and over and over again. I think actually this package example is a perfect example, because if you follow VGV's blogs and things like that, you'll know like we're huge proponents of modularizing your code base and breaking things down into sub packages wherever possible. And so things like that, also creating like CI workflows and other tasks that you do pretty often, but aren't necessarily trivial to do, kind of would slow things down as a developer. Like you might spend 30 minutes just creating like a base package and then create a PR, have someone review that PR, and then finally you're ready to start actually doing the implementation. And so that was kind of like area where we felt like we can improve our efficiency as developers and kind of leverage some sort of tool to define those things once and still have the flexibility to make them our own. I think that was the key differentiator, and then be able to leverage those templates over and over and over again. And so it started off just by analyzing like what already existed, and the closest thing in the Dart ecosystem that we found was Stagehand. And for those of you who don't know Stagehand, I think it's deprecated now because it's built in, or it got pulled into the Dart and Flutter tooling, but it was a standalone tool that's on GitHub that you can check out, that basically does a lot of what Mason does, except for all the templates that it supports are baked into the CLI itself. So you can do like Stagehand and then make Angular Dart project, or Stagehand and make a Dart package, just like we did here. The problem is like the contents of those things that were generated were all pre-baked into Stagehand itself. So as a developer, if you wanted to make your own modifications to the output of Stagehand, you had to fork it, change the templates, and then use your forked version, which wasn't really convenient. And so kind of Mason was basically like, okay, what if we could take what Stagehand did, but decouple the templates from the tool itself and let the tool operate on templates that are independent from the tool, that are hosted on Git, hosted locally, eventually maybe hosted on some shared registry where people can upload them. And so, yeah, a lot of it was inspired heavily by the Stagehand implementation that the Dart team created. So that's a bit of the history. And then from there, it became like a thing that we use a lot internally, as well as we open sourced Very Good CLI, which is basically super heavily dependent on Mason. So anytime you use Very Good CLI to create a Flutter package or a Dart package, it's basically doing what we just did right now under the hood. It's doing, where is it? It's doing this internally. So actually, if you haven't already looked at the Very Good CLI code, I definitely recommend take a look. And if you look at it, you'll see that more or less this code you'll find inside of Very Good CLI. And so now you know pretty much how Very Good CLI works, and you can make your own.
All right, one last question. Alejandro wants to know, is there a way to create a brick that outputs a Markdown file which injects the content of other brick generated Markdown files?
Yeah, we didn't talk about that. That's actually another good question. Mason does support partials, which are basically standalone brick templates that are shared across multiple bricks, and you can reference and inject, like you mentioned, across the board. So for example, common use cases like let's say you have I don't know, some sort of document that always has like a consistent header and footer. And like, let's say you have like 15 of those documents, and you don't want to duplicate the header and footer code everywhere. You want to have a single place where you define that header and a single place where you define that footer. And then you just inject those templates into all the documents. You can do that with Mason using partials. And hopefully I'm answering your question. So partials are basically just mustache. Again, they could be anything. The key thing that differentiates a partial is the syntax where you specify that it's a partial with this tilde symbol. So now header and footer are partials, and they won't actually be rendered when you run Mason make, but instead within your regular brick code, you can reference those partials, and Mason will basically render those partials independently. Like, let's say this is the content of header and this is the content of footer. You can still have variables and things, and it's still all rendered by Mason using Mustache, but now you can inject those in other templates and share that template code like all over the place, basically. So hopefully that answers your question. And I did not talk about that, but that's something that we can maybe do a separate episode on and talk about more advanced use cases and talk about partials and things like that.
But it does look like the README is pretty thorough, so definitely check that out first.
Yeah, if there's anything missing from the README, either open a PR or open an issue and let us know, and we'll try to update it pretty quickly. But yeah, we've tried to keep the README pretty comprehensive so that if you have questions about anything, hopefully they're somewhere in the README. I'd start by like just looking at the table of contents and then jump to whatever section seems relevant.
Cool. Well, thanks, Felix. Thanks for the questions from everyone in the audience, and thanks for attending. If you want more info on Mason, you can check it out on GitHub. I think it's on pub.dev as well.
Yep.
Right. We also have a blog on it on the Very Good Ventures blog, so definitely check that out. If you haven't been to our website before, this is the website. You can click over to the blog, see all of our content there. Yeah, do you have anything else that you want to say before we sign off here?
No, just let us know if you like this format, and maybe we can do more in the future. And yeah, if you have questions that you think about later that maybe you didn't have a chance to ask now, you can always tweet at us or just open an issue on Mason, and we'll try to get to it as soon as we can. So yeah, definitely let us know what you liked, if there are things you didn't like, and then we'll try to incorporate all that feedback in future sessions.
Yeah, and if you want more live streams, let us know. Like, subscribe, hit the subscribe button.
Yeah,
what do all the
YouTubers
say?
Which we don't know because we're not YouTubers. Yeah. But again, yeah, thanks everyone for joining. Hopefully this was helpful, and I'm excited to see what people build with Mason. If you build something cool with Mason that is okay to open source, please let us know. We always love to see cool things that people have made with Mason. So definitely like tag us on Twitter or let us know. And yeah, share with the community as much as possible.
Cool. Well, thanks everyone.
Thanks everyone.
Have a good day. See ya.
Take care.